High on Bolivia's Altiplano, Pumapunku's H-Blocks have been called proof of alien engineering and dismissed as simple stonework. Both sides repeat the same LIE, that this debate is settled. It isn't. Archaeologists confirmed the coarse shaping, hammerstones, known quarries, human labor. But when it comes to those millimeter flat surfaces and precision-fitted angles, the published record goes quiet. And that silence is where the real story begins. Jean-Pierre Protzen and Stella Nair spent years in the field at Pumapunku, measuring, sketching, and testing every theory they could put to the stone. Their notebooks record a clear pattern. The rough shaping of blocks, especially the red sandstone giants, shows unmistakable traces of hammerstone work. Pecks, impact scars, and the occasional unfinished face all match what you would expect from pounding with hard river cobbles. The same basic technique found at Inca sites hundreds of kilometers away. The main sandstone quarry sits about 10 kilometers from the platform, close enough for teams to drag or roll blocks up the gentle incline. For the andesite, the journey was far harder. Quarry sites on the Copacabana Peninsula lie across Lake Titicaca, some 90 kilometers distant. Even the smallest H-blocks, carved from this dense volcanic rock, would have required a coordinated effort to transport. But the real puzzle is not how the stones got to Pumapunku, it is what happened next. Protzen's detailed measurements, later used by Alexei Vranich for computer reconstructions, reveal that many of the andesite blocks fit together with astonishing precision. Some surfaces are flat to within a millimeter across their entire length. The H-blocks in particular display crisp right angles and parallel grooves that run the full depth of the stone. Yet in all the years of excavation and survey, no one has found the finishing tools that would be needed for such work. No copper chisels, no bronze punches, no straight edges, not even obsidian blades, which Nair demonstrated could produce sharp interior corners in experiments, have turned up in the debris around the site. The absence is striking, especially given how much stone debris and broken tools are typically found at other ancient workshops. Archaeologists agree on the basics. The Tiwanaku builders shaped these stones by hand, using the tools and materials available to them. The marks left behind confirm it. But when it comes to those mirror-smooth faces and perfectly matched joints, the evidence runs out. The published record, including Protzen and Nair's own work, acknowledges the gap. The question is not whether humans built Pumapunku. It is how, with nothing more than stone hammers and sand, they achieved tolerances that modern masons would measure with calipers. That is the legitimate mystery, one that is often buried under louder, less honest debates. Wild claims about Pumapunku's H-blocks have spread across documentaries, websites, and comment threads for years. Stories range from laser-cut granite to blocks weighing 800 tons, or even that the site was built 14,000 years ago by a lost civilization with forgotten technology. None of these stand up to scrutiny. The H-blocks are not granite or diorite. They are andesite, a volcanic rock, and the largest slabs are red sandstone. Petrographic analyses confirm this, matching the stones to known quarries. Red sandstone from about 10 kilometers away, andesite from the Copacabana Peninsula, roughly 90 kilometers across Lake Titicaca. The heaviest single block at Pumapunku tips the scales at about 131 tons, not 800 tons. Radiocarbon dates from the deepest fill layers beneath the platform consistently fall between 580 AD and 720 AD, placing the construction within the Tiwanaku era, long after the last ice age. Even the idea that all the H-blocks are perfectly identical does not hold up. Alexei Vranich's reconstruction project, based on field measurements collected by Jean-Pierre Protzen and others, used photogrammetry and three-dimensional modeling to digitally reassemble the platform. What he found was a remarkable degree of consistency, but also subtle differences between blocks, slight variations in height, depth, and groove placement. The puzzle-like fit comes from careful planning and skilled workmanship, not mass production or poured molds. Some viral videos claim the blocks were cast on site from a mysterious geopolymer concrete. This idea, promoted by Joseph Davidovitz and Luis Huaman in two papers published in 2019, is often described as peer-reviewed. While their studies use scanning electron microscopy and X-ray diffraction to argue for an artificial stone matrix, the evidence is based on a handful of samples, and no independent laboratory has replicated the results. The mainstream archaeological consensus remains that the blocks are quarried natural stone, shaped and finished by hand. The site's real mystery is not whether humans built it, but how the Tiwanaku masons achieved such tight tolerances and crisp geometry with the tools and materials available. Sorting fact from fiction clears the way for a more interesting question. Instead of asking whether Pumapunku was built by aliens or with lost technology, the evidence points to a human achievement that still challenges our understanding of ancient engineering. With the myths set aside, the real puzzle comes into focus. What methods could produce this level of precision using only the resources confirmed by archaeology and material science? Joseph Davidovits and Luis Huaman stepped into the debate in 2019 with a claim that breaks from both mainstream archaeology and the usual conspiracies. Drawing on laboratory work with scanning electron microscopy and energy dispersive spectroscopy, X-ray diffraction, and thin section petrography, they argued that at least some of the stones at Pumapunku are not carved at all, but cast in place using a kind of ancient geopolymer technology. Their team collected tiny samples, fragments gathered in 2017, from both the red sandstone platform blocks and the andesite H-blocks. Under the microscope, the sandstone samples revealed what they described as an amorphous ferrosialate matrix, a binder that, in their interpretation, did not match any naturally occurring cement or geological process from the region. The andesite samples, even more surprisingly, showed traces of organic material, carboxylic acids embedded within the stone, something that should not be present in volcanic rock formed at high temperatures. The analytical results came from standard methods in materials science, including scanning electron microscopy and energy dispersive spectroscopy for imaging and elemental composition, X-ray diffraction for identifying crystalline phases, and thin section petrography to look at the relationship between grains and matrix. The red sandstone, according to their published data, contained sand grains that matched the Calamarca quarry, but these were locked in a matrix with high sodium and iron content, suggesting synthetic origins. For the andesite, the presence of organic matter, if truly ancient and not contamination, would point to a human-made binder rather than a product of volcanic activity. Davidovits and Huaman published their findings in 2 peer-reviewed journals, but the evidence is preliminary. The entire argument rests on a handful of samples, just a few grams each, and no independent laboratory has replicated their results. The papers do not provide full data sets, chain of custody details, or raw micrographs for outside review. Even so, their hypothesis is not easily dismissed. The possibility of a cast stone process, using local minerals and plant extracts to make a kind of concrete, would explain how the Tiwanaku achieved such crisp geometry without leaving behind finishing tools. But without broader testing and open data, the geopolymer idea remains a credible but unverified alternative. For now, the mainstream view holds: the stones are natural, quarried, and finished by hand, yet the door remains open for new evidence to change the picture. Heather Leckman's work on Andean metallurgy brings a different kind of puzzle to Pumapunku. Archaeologists have recovered dozens of metal clamps, sometimes called cramps or staples, from the site. These were poured molten into precisely carved grooves, locking blocks together across seams. Chemical analysis shows the clamps are a ternary bronze, copper alloyed with arsenic and nickel. Producing this metal at nearly 4,000 meters elevation was not just a matter of digging up ore. It meant building furnaces that could reach over 1,000 degrees Celsius, controlling the mix of trace elements and casting the alloy on site before it cooled. The clamps fit so tightly in their sockets that some researchers wonder if the stones and metal expanded and contracted together, binding the platform even tighter as the temperature shifted on the high altitude plain. The challenge of moving these stones is just as daunting. In 2002, Alexei Vranich organized a full-scale experiment to see if the traditional story of transport held up. A 9-ton andesite block, roughly the size of a small H-block, was loaded onto a reed boat built by Aymara craftsmen, floated across Lake Titicaca, and then hauled up the final slope by a team of 50 people using ropes and wooden rollers. The block arrived intact, proving that at least for stones of this size, the combination of lake transport and human muscle could work. But the largest sandstone slabs at Pumapunku weigh more than 130 tons. No experiment has managed to move anything close to that scale, and the abandoned half-carved stones along the ancient roadways suggest that even the Tiwanaku ran into limits. There is no evidence of ramps, pulleys, or lost machinery that could solve the problem. The logistics of moving and lifting such masses remain an open question, one that does not fit neatly into stories about superhuman technology or simple brute force. It is a reminder that the real frontier is not in the myths, but in the engineering challenges that still have not been fully explained. Today, no peer-reviewed study fully explains Pumapunku's sharpest stonework. The real question isn't aliens or certainty, it's how this exact precision was possible with the tools confirmed so far. Until new evidence emerges, the stones keep their secret. What do you think is still missing from the puzzle?